Hello, bonjour, everyone. Hello. Thank you so much for joining us today. Merci de vous joindre à nous aujourd'hui. Euh, donc, bonjour tout le monde, bienvenue à l'énergie solaire avec Shift. Welcome everyone and to Solar 101 with Shift. For those of you who don't know me, my name is Annika Chiasson. I'm the Executive Director of the New Brunswick Environmental Network. Donc, pour ceux qui ne me connaissent pas, je m'appelle Annika Chiasson, je suis la directrice générale du réseau environnemental du Nouveau-Brunswick. Today, I'm joined by Chris and Tim from Shift. We'll be doing about 30-minute presentations followed by a Q&A period, an opportunity for discussion. Donc, je suis accompagnée aujourd'hui de Chris et Tim de Shift. La présentation va durer environ 30 minutes, puis ça sera suivi par une période de questions-réponses et discussions. Couple of housekeeping notes before we get started. We have interpretation available. If you would like to use it, all you need to do is select the button on the bottom right of your screen that's labeled interpretation that looks like a little globe and select English if you'd like to hear everything in English today. Donc, on a de l'interprétation de disponible aujourd'hui. Si vous voulez l'utiliser, il suffit de cliquer sur le bouton en bas à droite sur votre écran et sélectionner français ou French pour tout entendre la présentation en français aujourd'hui. Également, nous sommes en train d'enregistrer la présentation. Donc, si vous ne vous sentez pas confortable d'être sur l'enregistrement, sentez-vous libre d'éteindre votre caméra. Additionally, we are recording this event. So if you do not feel comfortable having your picture recorded, feel free to turn off your camera and leave it turned off for the event. Very last thing before we get going, I'd like to acknowledge that those of us who are living in New Brunswick are doing so on the unceded and unsurrendered ancestral land of the Mi'kmaq, Wolastoqey, and Passamaquoddy peoples. And it is through the treaties of peace and friendship first signed in 1726 by the Wolastoqey and Mi'kmaq with the British Crown that we're able to enjoy and inhabit this land. So if you'd like to share where you're joining us from today and which land you find yourself on, you can do so in the chat. We'd love to see where you're joining us from. And without any further details, I'm going to hand it over to Chris and Tim.
Wonderful. Thank you very much for having us today. My name is Chris. I'm the community manager at Shift. Also on the call, actually, I see is Stephen Peacock, who's a solar consultant in New Brunswick for Shift. And then also Tim Grandjean. Tim, if you want to introduce yourself. And Stephen, since you're on the call, if you want to say hi as well.
Yeah, thanks, Chris. Tim Grandjean here with Shift Energy Group, Director of Project Development, joining from Nanaimo, British Columbia today.
And if Stephen is there, maybe not, maybe he's gone. All right, well, we'll catch him if he's back. Yeah, I'm in Victoria, British Columbia, actually. A little bit about Shift just before we dive in. Shift was started in 2010 by Colin Strong on Vancouver Island. In 2017, Shift turned its focus from LED retrofits to solar and energy storage, and that's exclusively what we do. And business is booming, to say the least. So we started in Victoria, we expanded to British Columbia, then we went to Nova Scotia, and we're actually now in New Brunswick. So a big part of our plan, if you will, when we expand is community is everything. And so the first thing that we wanted to do was reach out to the community and just offer some free community engagement when it comes to solar, because I believe the path forward, and we all believe the path forward with solar, is education. And there's such an opportunity in this country because Canada is in its infancy when it comes to solar. It's such an opportunity to just get out and be the place where people learn things. My belief is when people learn from you, they promote you. And so that's kind of the whole strategy with this. It's not a sales thing. It's literally just to introduce you to solar, answer questions about solar, and have a discussion today. So thank you very much for having us today. We're excited to partner up. and I'll just dive right in if everybody is okay. I figure I'll just get moving through the PowerPoint, and then after that we can sit and have a conversation, and so jot down your questions as I fly through. So I'll just begin to share my screen here, and we will dive into Solar 101, I guess is what we're calling it. Okay, so everyone can see that? Thumbs up. Yeah, perfect. Thank you. All right, so it's all about solar PV energy today, not to be confused with solar thermal PV, photovoltaics, turning light into electricity. That is our focus. So I just grabbed a few slides. So the first thing we always face in this country when we talk about solar doesn't work in Canada. Are you kidding me? You know, with our winters and our cloudy winters, and it doesn't work. This is just kind of a little slide to show that, you know, we actually do pretty good when it comes to sun hours in this country. As you can see in Vancouver, 1938, looking at Moncton, New Brunswick, and some other in New Brunswick, totally comparable. In fact, in Dalhousie, you know, 2028 hours. If you compare that to the rest of the world, like Berlin, Germany, they've been actively using solar since 95. They're way ahead of us, and they don't get near as much sun as us. So in terms of sun hours, Canada does all right. And of course, thanks to net metering, where we can store or bank our excess solar energy in the grid, we can still use solar energy throughout the year. I'll talk a little bit more about net metering as we go further into this. This is going to be shared as well, so you can go back and look at these numbers if you want. Solar 101, the basics of photovoltaics. Photo meaning light, voltaics, or volt, meaning electricity. The very basics of it: in all light, there's what's called photons, and what's happening when it comes to solar energy is those photons are crashing into a solar panel and causing the electrons to move around. That movement generates electricity. That electricity is captured by a semiconductor and sent off to your main service panel to power your home or whatever you need. That's the basics of it. This is where in my in-school program, I get the kids up to dance. And when the classroom lights are on, the kids start dancing. And when they're off, they freeze. And we have some fun with it. I won't make you do that today, but just to get a basic idea of how solar works. It's movement. It's just like movement in a hydroelectric dam or a wind turbine. Movement is generating electricity. It's happening at a molecular level, and you just can't see it. Now, another term you're going to hear in solar a lot is kilowatts versus kilowatt hours. So you're going to hear people say, oh, that's a 5 kilowatt array. That's a 10 kilowatt array. And it produces 10,000 kilowatt hours per year. Well, the difference is kilowatts is power at a time, and kilowatt hours is power over time. So a 1 kilowatt heater equals 1 kilowatt, but a 1 kilowatt heater running for an hour is 1 kilowatt hours. So as you can see, an 8 kilowatt solar array in ideal conditions, of course, might produce 8 kilowatts in direct sunlight at a time, but over the day, it could produce 20 kilowatt hours. Now, how it works with your home: the solar panels essentially sit on your roof, and those electrons, those photons, cause those electrons to start moving, generating electricity. Now, we have to turn that electricity from DC, because solar panels produce DC, into AC. There's a battle a long time ago, and it was decided that AC is what we would use in our homes. So we need to invert that. So DC to AC. Now, there's different types. You have string inverters. Two different types. You have a string inverter, which is kind of like Christmas lights. They're all connected on one string. However, when one is shaded, then they're all going to be shaded. So what we have to solve that problem is called optimizers. So essentially, it's a string inverter, but every panel has its own optimizer, which will essentially predict if one panel is shaded, only that panel will be shaded, and everything else will perform. At Shift, we use a lot of what's called microinverters, which means the inverting from DC to AC is happening on the roof. So the panels go into the microinverter, which just sits on the racking under your panel, and the DC is converted to AC, and then you have AC going into your home to your main service panel. We find that's the way to go right now in terms of cost and efficiency. So we're using a lot of microinverters, but we do install other types. on big projects, which we can talk a little bit about later. Once it's converted to AC or inverted to AC, it goes to your smart meter, and your house, or I should say, goes to your service panel. Your house uses it first, and whatever you have not used in your house gets sent to your smart meter and sent to the grid. And of course, that's where it's tracked for net metering. Now, speaking of net metering, what is it? Well, I touched on it earlier. Basically, it's the ability that we have across Canada to store or bank our excess solar energy in the grid. And at the moment, it's 1-to-1 kilowatt hours. So you produce 1 kilowatt hour, then you get 1 kilowatt hour back in the winter or at nighttime when you can still use that solar energy. So you can see here on an example of a bill, inflow is what you're bringing from the utility, outflow is what you are sending to the utility. You do the math on that in this bill as an example. You have a 0 kilowatt hours, no bill, which is the goal. Now, in terms of, how much you can produce, actually, we'll talk about that a little bit later. I'll just jump into what it looks like in Canada right now and solar in Canada. In 2010, total installed solar capacity was 221 megawatts. Now we're up past 3,500 megawatts. So the boom is happening right now. Of course, a large part of this boom is because Canada has a plan to achieve net zero emissions by 2050, and renewables is expected to replace the share of fossil fuels in the energy mix. So it's an incredibly ambitious target, and it's doing nothing but helping us, and solar is a wonderful way to reach that. Top provinces: Alberta, Manitoba, Saskatchewan, the prairie provinces. Obviously, they do get a big sky country. They do get a lot of sun. Ontario, and then BC and the Atlantic provinces, which of course include New Brunswick, are catching up. And those provinces are applying a lot of great incentives, which we will touch on as well. I love this one. Currently, there's about 500,000 Canadians working in clean energy. By 2050, that's going to go up to 2.7 million. Now, we will lose jobs in fossil fuels as we transition. But at the end of the day, when you do the math, roughly they're saying we're going to have about 700,000 more jobs in renewable energy. Now, that's wind, that's solar, geothermal, whatever it is. So there's lots of opportunities. If you're looking for work in renewable energy, it's coming. For an example, Shift started, I think, 3 years ago with something like 12 employees. 7 years ago, it was Tim and Colin. And so, now we're sitting at, I think, 65 employees. So the growth is happening in the industry. I do want to touch on challenges with solar, and anytime I do a presentation out in the community, people always ask about these things. So I figure, hey, let's talk about it right now. Mining, manufacturing, and transporting of solar panels. Yep, that all has to be done. And right now, predominantly, it's using fossil fuels. These numbers are pretty cool. We got to mine for renewable energy about 7 million tons a year. But for fossil fuels, we're mining 535 times more, about 15 billion tons of minerals from our planet every year. So yeah, we're still mining for renewables at the moment, but it is nowhere near what we're doing for fossil fuels. And this is cool as well. Yeah, to transport the panels and like I said, manufacture, we're using fossil fuels, but it takes about 1 to 2 years of a solar panel's working life to create enough clean energy to offset the bad energy that was needed to create that panel. And panels are going to go at least 30 years and beyond. They degrade 0.5% every year. And there's no moving parts. There's virtually no maintenance with a solar panel, so they can last quite a long time. So 1 to 2 years creates enough clean energy to offset that bad energy. The other challenge, of course, is recycling. It's 300 times cheaper to just throw it in a landfill than to recycle a solar panel. That's a problem. So a lot of people are throwing them in landfills, which is not good for the environment. We don't want that. The great thing is, it's kind of, I look at it kind of like, cans and bottles. 20 years ago, we weren't recycling those. The more and more, all of a sudden, these showed up, and we're like, man, we got to do something with these. Then all of a sudden, it was decided, hey, let's recycle these. It became a business for somebody to do. And so that's the way I see solar going. The more and more panels we get out there, the more and more it will become a business for somebody to recycle them. The U.S. government just invested $80 million in a program. The Alberta Recycling Management Authority, we have a podcast called the Solar PV Cast. Here's a plug for it. Had a great conversation with them, and they've started a free recycling program to help solve this problem, because they're seeing a lot of solar panels coming back to them in Alberta. And Shift, we've partnered with local farmers on Vancouver Island. Actually, maybe this is something we would like to expand across Canada. But when we have panels that aren't performing 100%, Shift actually has a production warranty, and if your system does not produce what we say it will over the 25 years of this warranty, we'll actually cut you a check. So because of that warranty, if a panel's not producing, then we go flip it out. Now, maybe that panel's only 2/3 working. So actually what we do is start an upcycling program. We donate those panels to local farmers, because the panel is still producing. It's just not 100%. So we donate those to local farmers. And that program has seen a lot of growth and great feedback. Benefits to the environment, roughly speaking, some numbers. 8 solar panels will provide about 40,000 kilometers of range a year for your EV. 16 panels, 46 trees a year, and 24, you're removing 2 gas cars from the road each year. Now, reasons why a lot of people are looking at solar as an option. Basically, you have both sides of the aisle meeting in the middle now. They make money and they help the environment. For a long time, everyone thought, oh, they just help the environment, but the cost. 10 years ago, a panel was $1,000. Now one solar panel, maybe $300-400. So costs have come down almost 90% in the last 10 years. So now it's affordable, and it's better than your standard GIC investment. So you're making money by going to solar. So like I said, that's got the other side of the aisle saying, oh, okay, yeah, I'm finally into this thing. Right, it helps the environment. And then, of course, you've got everyone on the environment side saying, this is the way we need to go. Climate change is real. It is happening. We're moving too slow. So energy independence is another main reason people are looking at solar, especially in the Atlantic provinces where, I think it's 17 cents a kilowatt hour in Nova Scotia and New Brunswick. So all of a sudden, when you can lock in your energy cost for 25 years and those rate increases don't affect you, yeah, sign me up. Well, you can do that with solar. Credits, like we talked about with the net metering program, allows you to use your solar energy that you produced in the summer, use it in the winter. You can sell your home for more. Roughly, we say, it's equal to the cost of the system installed. It's going to up the value of your home. However, the more and more, I like to think of it kind of like EV chargers. Maybe 5, 6, 7 years ago, nobody was asking for an EV charger when they were buying their home. Now they want an EV charger. Well, solar's the same. Right now, nobody's saying, I want a house with a solar system. But, maybe 5, 6 years, people are going to be asking for a home that has some form of self-generation. And that's only going to help the resale. And then, as we talked about, of course, climate change contribute to a greener future. Government support. The Canadian government had a program called the Canada Greener Homes Program. They had a grant. Unfortunately, it was so popular, they had to stop that prematurely. It was $5,000, but the loan is still going. This is a 0% interest, 10-year payback federal government loan up to $40,000. In New Brunswick, they also have $200 per kilowatt, up to $3,000 rebate through the Total Home Energy Savings Program. So you can combine, you get $3,000 off your system, and then you put the rest onto a 0% interest loan, virtually no money out of your pocket, and of course, no interest, free money from the government. Yeah, I'll take that for sure. On the business side of things, on the commercial side of things, this is Tim's department, so he's the guy to answer questions on this in a second. The ITC, the federal government investment tax credit, that's up to 30%. And that's to get businesses focused on net zero technologies, battery storage solutions, and clean hydrogen is in there as well. Now, the rough costs of going solar. As you can see on the screen here, smaller home, 4 to 5 kilowatt, 9,000 to 15,000. Average home, 7 to 10, 16 to 28. Now, there is obviously this is a big ballpark, but it's because there's so many factors that go into sizing a system. Some ways to bring that number down or consume less energy, which at the end of the day is something we're all trying to do. Less energy, less panels, less money. Maximizing capacity. So on a roof, if we have to do many different arrays, then it's just you have to run more wires to each array. So if you had, a wide open roof space with just one big array, that'll save you some money. Use powered outbuildings, and go solar when you replace your roof, because again, these panels will last upwards of 30 years. So a good time to do it is when you redo your roof. What makes a great solar array when looking at your home? I just talked about a few of them. Obviously, obstructions, big trees, big buildings. We need that light. We need those photons. Room on the roof. If you got lots of peaks and valleys, it makes it hard to put a rectangle solar panel in some of the triangle shapes. Dormers, plumbing stacks, skylights. Sometimes they build homes that say, oh, this home is solar ready. Yeah, it's great. It's perfect. Oh, that's wonderful. You've put skylights everywhere where the solar panel goes. So that makes it really challenging. So things to consider, if you're designing or building your home. Angle. What is the ideal angle for mounting a solar panel? Well, the ideal angle is, if you're mounting it in New Brunswick, is essentially equivalent to the latitude. That's the ideal angle. However, the cost for the materials to mount that solar panel at the ideal angle will hurt your return on investment. So honestly, we mount solar panels equivalent to the angle of your roof. Or if it's a flat roof, we can angle them up no more than 10 degrees. And it's gonna, your return on investment is still solid, and it's going to be a heck of a lot better than mounting it at 45 degrees, 47 degrees, whatever that latitude is. So financially, it makes the most sense just to mount it on your roof, whatever angle that is. And we have many different systems to mount that on your roof, whether it's asphalt shingle, standing seam metal, flat roof, torch on, whatever it is. There's many ways to do it. Orientation, south is ideal. That's where the sun is all the time. East and west, of course, work as well. And actually, with panels getting more and more efficient, even north, our lead microgrid development has actually mounted panels on the north side of his roof because it's such a low slope. And they're actually doing quite well because he's got some older panels, he was telling me, that don't produce as much. So these 500-watt panels on the north are actually producing more than his older 250-watt panels on the south. So again, it all depends. And then breaker panel size. 100 amp service. A lot of older homes in Canada are 100 amp service. So that is going to limit you. I should say it's a 100 amp bus bar, which is important as well. We can talk a bit more in detail about that if you have more questions, but just I wrote down 100 amp service gets you 12 panels, 125 amp bus bar gets you all the way up to 30. I'm not an electrician, but there's some electrician math in there that makes sure it's safe for everybody. Okay. Design. So this is something that we do at Shift. We do complimentary, totally free, no obligation quotes. And this is what our solar designers use. It's a program called Aurora. And essentially, they make a 3D model of your house, as you can see here. And the orange is, the brighter the orange, the more sun is shining on that spot part of your house. So we find out where the sun's shining. We find out where we can fit those panels. And we do a 3D design. We take into account, this program is called LiDAR on the right picture. And that tells us the heights of everything. This is how we essentially give you that 25-year production warranty as well, because we're so confident in this technology that we can say, yeah, this system right here is going to produce this over the next 25 years based on this, this, and this. And we take into account snowfall. So the average amount of snowfall in your area, we take into account soiling. And then you can see the finished product. That was an install we did right there. Yeah, any questions about snow which come up, that is a thing for sure. We take all that into account. And honestly, we don't recommend removing snow because the production you lose when it's covered in snow, you make up in an hour in the summer. Yeah, something to think about. All right, energy storage. We're moving quick, only a couple more to go. This is good. Energy storage, that is something Shift does as well. Tesla Powerwall. This is kind of the main thing we do. We do all types. We have an off-grid specialist, and we do Solarc as another company we use. But Tesla is kind of the big one a lot of people ask about. There's some rough costs of it. This is the Tesla Powerwall 2. The Tesla Powerwall 3 has just come out, and that is what we're looking to install in the near future. And the costs for that are a little bit more. But energy storage is, you don't need it if you're tied to the grid and the grid's reliable. However, if the grid's not reliable, then yes, definitely you should consider energy storage. Also, energy storage is the way of the future, because time of use billing is a thing. I understand it is a thing in parts of New Brunswick, same for Nova Scotia. Essentially, you're paying more to charge your EV between 4 and 9 p.m. Well, if you had energy storage, you could charge it on the cheap times effectively, and then use it to charge your vehicle during the expensive times. So we're seeing a lot more interest in energy storage. And if we look through the crystal ball that is California and other parts of the United States, as we can see with their brownouts and things like that, energy storage is becoming more and more important, and it is the way of the future as well. Speaking of the way of the future, building integrated photovoltaics. This is something that Shift firmly believes in, and we are the exclusive installer of this product in Canada. It's essentially 2-in-1. Instead of putting solar panels on your roof is solar. And this is an install we did. You can see the solar kind of on the left there. Otherwise, it's pretty seamless with a standing seam metal roof. And we have version 2.0, which is coming out in the near future, which we've kind of dialed in a little bit more. We're really excited about that. So essentially, this answers the aesthetics question when it comes to solar, and it also addresses the future of new development. You know, we're no longer, before we just built a home and that was that. Now we're building homes thinking about how can we add solar. Well, this is how you do it. So when you're designing your home, you make a nice big open flat section pointing south, and you install this type of roofing, and you're done. So we're really excited about that. In fact, that's what is behind me when I jump back into a second. I have an example of it. Solar projects. We've done a number of big projects. We have British Columbia's largest rooftop solar installation in Vancouver. And this is, I'm not sure where this stands in terms of New Brunswick in this size. Maybe Tim can answer that. But this is a project we did in Miramichi, New Brunswick, 233 panels, 106 kilowatts, producing almost 110,000 kilowatt hours a year. We did this one a couple years ago, actually. Yeah, beautiful install. So if you're ever in the neighborhood, make sure you look up and check that install out. Thank you, Mel C. I hit that almost 30 minutes bang on. Let's have a conversation and answer any questions you have about solar.
Great, thank you, Chris. Feel free to either use the raise hand function, donc sentez-vous libre d'utiliser la fonction pour lever la main. Or if you prefer, you could also write your question in the chat and we can go from there.
Okay.
Vas-y, Doris. Ah, t'es sur mute, Doris. On t'entend pas.
Moi, j'ai une question concernant la pesanteur des panneaux solaires sur un toit. Disons, il faut que ton toit soit assez solide pour les soutenir.
Donc,
Chris, you want me to take that one?
Oh, sorry. Tim, you got that?
Sure, yeah. Donc la pesanteur, c'est normalement pour une toiture, how do I say sloped?
à pitch.
Ça fait à pitch, ouais, ça fait moins moins que 3 livres par pied carré.
OK,
Donc,
par pied carré.
moins, ouais, donc c'est moins it's less than a layer of asphalt shingles in terms of weight. Pour les toitures qui sont plates, on approche 5 à 8 livres par pied carré.
OK.
Est-ce que ça répond à ta question, Doris?
Non, ça dépend de ma question. Et puis, les panneaux solaires qui sont maintenant intégrés dans le toit, c'est la même chose pour la pesanteur?
Environ 3, ouais.
Oui, la même chose. D'accord.
Okay. Lee, I see you have your hand up.
Yes, other than Tesla, what other battery storage systems are approved and certified in Canada?
Tim, you're up.
Is that me? Okay. Yeah, so Powerwall is generally the go-to solution that we have. In its classification for like a lithium-based solution, with a 10-year warranty and an unlimited cycle life, it trumps every other option in terms of cost, making it our first choice. There are other solutions available. We know that not everybody necessarily wants to support Tesla, and sometimes there are merits for a different solution. So there's home grid batteries, and those are kind of our second choice or our alternative, which we would integrate with a different inverter. It could perhaps be a solar inverter. And those are kind of the main two that we work with. Chris had touched on our off-grid department, and you know, in that category, we will look at AGM and other sort of 48-volt battery banks as well. I hope that answers the question.
Yes, it does, because the certification, being a small market compared to the States for home storage, is just starting to develop, I think. Do you have any sense of where we are with being allowed to have an LFP backup battery in the house as opposed to in a heated outbuilding?
Yeah, the 2021 electrical code, which is currently what we're operating under, when that code came out, it brought a lot of constraints and limitations to how much capacity we can install in a home, where we can install them, what sort of clearance requirements we have from, you know, windows or doors or you know, gas lines, and batteries. The 2024 code has just come out. I haven't checked for New Brunswick yet, but I know here in BC we're adopting it. I believe it's in the spring. And that new code does clarify quite a few of the sticking points that we had, and gives us a little bit more liberty. In general, though, in terms of LFP in a home, we want to limit installations in habitable spaces, you know, bedrooms or rooms that open into bedrooms or living spaces. So generally we're looking for garages, exterior walls of garages, and those could be attached or detached, as well as, you know, basement utility rooms or mechanical rooms, things like that.
Okay, I guess a third question would be, I have clear access to the sky with no obstructions, whether I put it on a barn or whether I do a ground mount. I'm puzzled because a lot of people are recommending, a lot of companies are recommending the microinverters. But I don't have the problems that microinverters, are designed to deal with, like shading and things like that. It's an extra expense that I'm not sure why it's necessary.
Yeah, so one of the things that so I can maybe start with roof mount versus ground mount a little bit. Roof mount is going to be the choice that offers a lower investment up front. The cost of going with a roof mounted solution typically is far less than a ground mount. Primary reason being is the ground mount, we're now turning this solar project into a little bit more of a civil project as well, including foundations and, trenching for a wire run. Then you have the cost of that wire run or the cabling itself. As a rule of thumb, I would say a ground mount is typically going to cost maybe a third more than a roof mount, apples to apples. That being said, sometimes a ground mount does give you a better exposure. Therefore, it may warrant, the price premium if the amount of energy produced is that much greater than the roof mounted option. Some folks also just prefer to have it on the ground. Maybe there's acreage, there's room, and you want to have the panels be accessible for cleaning or other reasons. In terms of the microinverters and cost benefit on that, in some cases using microinverters can still end up being more cost effective than a string inverter, simply because aside from the equipment and hardware costs, you're converting the DC into AC at the panel level or at the array level, which when you are bringing DC out of the array or beyond the array, there are added code requirements and complexities for the installation that sometimes drive up the pricing a little bit. But I would say on ground mounts, we do tend to use more string inverters, not always. But on roof mount, we typically would still go with a microinverter based solution rather than move to a string inverter, even if shading is not really a factor.
The issue I'm struggling with is a ground mount. It's more accessible for maintenance, but it's more susceptible to damage. My barn is a 2-story barn, so it's way up there to put the panels in, and I'm just worried about Murphy coming along with Murphy's Law, and the panel that acts up is going to be in the middle, and there's going to be a lot of service charges to get at that panel. It's either staging again or a big crane or something like that. It's what's your experience with that sort of ongoing maintenance of a system that's it's really up there?
Yeah. Yeah, I mean, I could say we've definitely seen worse. Chris might have touched on this a little bit. I was listening to the presentation in French, but we offer a 25-year labor and workmanship warranty, which matches the warranty period of the product that we install. So essentially, that would be a service call that would be on us, so long as it's not a failure due to, say, natural disaster. Solar panels have no moving parts, as you probably know. You sound very well researched. failure rates on solar panels are pretty few and far between. Generally, if something does go in a system, it would be an inverter or a microinverter. But again, that's why, we choose to install products that have 25-year warranties through the manufacturers, and then, back it up with our in-house warranty. So essentially that risk goes from being on you to on us. So it sort of becomes a moot point, more or less. So I would probably still go on the barn.
That's very interesting that you have, the 25-year service warranty as well. So, I'm not gonna have a truck roll cost from Moncton or Fredericton, into the north.
Yeah.
Yeah.
Yeah, so I mean, the standard in the industry is like 1, 3, 5 years. And a big reason why we introduced that is just it's primarily a testament to our craftsmanship and our our adherence to manufacturers' installation guidelines. So reading the fine print in installation manuals, ensuring that section 3.4.1 of the manual is followed, so that in the event that if something does happen, the manufacturer doesn't come back to you and say, hey, well, the installation wasn't done to our installation manual, therefore your warranty is null and void. So there's a few reasons why that's there, but we're really proud to offer it.
That's a big plus as far as I'm concerned. I mean, I know,
and it saves you a lot of money up front because, as Tim mentioned, ground mounts are obviously incredibly expensive when you start trenching and building a foundation and making it, rock solid for the windstorm that rolls through and things like that. Whereas on the roof's going to save you a whole bunch on the install. And then, yeah, in terms of maintenance, if there is any issue, then our guys will do that on us.
Okay, thank you. I'll stop monopolizing the conversation.
I see a question from
Thank you.
Ann there.
Yeah, exactly. Anne says, if you have an east-west facing roof, how does the amount of power produced compare with the southern exposure?
Yeah, I mean, that's a great question. I'm going to throw that to Tim, head of design. What does it look like when you're doing production east, when you have good east and west or a great south? I'm assuming south still wins, but Tim, enlighten us.
Yeah, so south still wins for sure. East-west roofs are still going to probably produce 80 to 90% of what a south-facing roof would accomplish. With east and west, the best case scenario is a lower slope east or west roof, just because it gives you more exposure to the sun throughout the day. Whereas if it's a very steep roof, let's say this is the east face facing this way, the sun's rising, it's coming, where am I going? South. As soon as 12 o'clock hits and the sun is here, if you're very steep, then you're in the shade at that point. But if you're pretty low slope, you're still getting some sun exposure that way. Yeah, 80 to 90%, I would say, most cases.
Do you have any follow-up questions, Anne? Might be typing here. While we wait for that, is there anybody else who has any questions?
It's the least amount of questions I've faced. This is great.
Oh, I think Shal has a question or a comment.
Yeah, excuse me. Yes, thanks. Quick question. So we have a solar installation at our community center, and NB Power, because we're commercial, even though we're nonprofit, we're considered commercial or commercial account now. What they'll do is they'll charge you per kilovolt amp instead of kilowatt, depending on the spikes of energy consumed and stuff. This might be getting a little bit too technical. But when we had a heat wave a few weeks ago, our ACs were working double time. So our electricity bill was actually higher now than it was before we had solar. So we've diminished our AC, or I guess we've increased our AC temperature, from a comfortable level to all right, let's just get rid of as much humidity as we can and diminish those kVA spikes to a level that is not over the kilowatt, and then we're fine. Is there any equipment we can install? I was looking at capacitor banks and things like this, but would a Tesla power wall help in that situation?
So Charles, you're looking at so kVAs would be kilowatts would be so you're looking at demand charges. Is that what we're because
Yeah, correct.
with commercial rates you have an energy charge and a demand charge, and so what you're saying is in the summer your AC load is going up, therefore increasing your demand or your kilowatts in real time. And
yeah, we can monitor with our system. It's when the compressors in the heat pumps light up. Those motors, they're not attenuated, I guess, or whatnot. Yeah, there's an energy spike when those happen, and they tend to cycle on and off quite often during the day.
Yeah, I mean, one of the things that we offer for demand management is energy storage. However, it does, it often is a numbers game. And demand side management, it's still something that to deploy batteries to offset demand charges, it's not quite as accessible as say a straight grid tie solar system. Would be interested in looking at it though. That might be something we could follow up on after the meeting, and just getting an idea of what the demand charges are and what that dollar per kVA charge is, and seeing if that's something we can't look at even just providing some high level feasibility on.
Yeah, I appreciate that. We are definitely keeping an eye on it. Like I said, we had set our cool point at like 22 Celsius, and we rose it to 25. And that seems to have brought us just below that threshold. So we're now back on the kilowatt hour type thing instead of the kVA. So that has brought us down to a normal type of operation. But yeah, it was interesting. This might happen again, climate change, yada, yada, yada. But yeah, heat waves are more prevalent. They will happen often. But yeah, I mean, just nipping that humidity out of the air helps a lot. You do feel the relief still while set at 25. It's a big community hall, right? You can probably seat like 300 people in there. So it's fine. And even just with a few fans, if that, but it's fine at 25. I was just wondering if we need to bring it back down to like 22, 21, if there's things we could install. But yeah, it seems to be manageable, but it's something we were not aware of, who reads the fine print from NB Power. And those rates keep changing all the time. You're right about that too. They just raised, I think, this week. The service charge rates are now increased in urban areas to the same as rural areas, and there's more changes coming this fall too. But welcome to New Brunswick, folks. Thanks.
Yeah, Charles, just one last thing on that. The other thing, it sounds like you're already looking at doing it is just phasing, because that peak demand charge is your max load at any given time, right? So if there's an opportunity to schedule different motors and compressors to start at different times, just because they do draw their most as soon as they turn on, that might help things as well.
Yeah, we're looking at all kinds of expensive solutions, but if we can attenuate it and not invest in other equipment, I think that's the best approach for a small nonprofit community center. Thanks again, guys.
Absolutely.
Tim, just follow up for me. Sorry. So you're saying essentially rather than everything coming on when everyone gets there in the morning, just kind of schedule it throughout the night, hey? And that would break that up? Yeah, or scheduling it throughout the morning or something like that. Yeah. It's easier said than done. Yeah, totally.
Yeah, we have
sometimes it works.
Energy monitoring software system, so it's not on during the evenings, but yeah, we're working on it.
Cool.
So we have a follow-up from Anne in the chat here. And I also see, Anne, you have your hand up, so perhaps you'd like to voice your own question.
Thank you. Yes, I was wondering, in the case of my property, I have a lot of trees. How would, are you able to determine to what extent the roof is shaded and what trees would need to be removed?
Yeah, for sure. I think I can get this, Tim. You can back me up on it. Essentially, what I talked about in the design, using a program called Aurora, they will take into an account all the trees around your area, and they'll figure out the heights of those trees and what that looks like. I mean, I don't know that they'll come out right and say, knock this tree down, because I always feel weird doing that when here we are trying to help the planet and we're cutting trees down, but it'll give you all the information you need in looking at the proposal and what maybe you could do if you want more light to hit your roof. So that would be included in the design.
And would you be able to tell what part of the roof was shaded?
Yeah, 100%. Yeah, that slide with the orange roofs of the house, if it's a dark orange, then that's got more shade on it than the bright orange. So you would see that in your proposal. And that's how we factor in, again, that warranty and guarantee our production, because we can say this panel's it's pretty unreal. I actually work next to the designers and seeing what they're doing. I can, if I'm going to fly the drone at a house, for example, and I want the panels to be in the sun, I'll say, hey guys, can you tell me here's the address. When are these panels going to be in the sun? And they can say, and I'll be like, oh, I'm going to go September 6th. And they can punch in September 6th, and they kind of move the mouse, and it's like 2:15 to 4:15. Those panels will have lots of sun on them. So it's really dialed in. It's really granular.
Yeah, because I was just wondering, how you would figure out if for instance, one end of your house got more sun than the other, but it would be best to use the entire roof, then I was just wondering how you would determine, like, would the shaded side be darker orange and the sunny side be lighter orange? Like, how would you see kind of where the light was falling?
Yeah, and this program does it. Technology. I think what is it, an azimuth? The old way to do it, but there's this program called Aurora.
Solar Sun Eye and yeah. There used to be tools, which when I was in school, that's what we learned, was how to show up to a property, and we actually use this device. It was like a globe, and you'd set it up on the property and mark out the sun path around the shade. But now with software and LiDAR, LiDAR gives us like a 3D topographic map of the area, and we're able to quickly pinpoint what obstructions are potentially impacting gains. And we'll never come out and say you should cut a tree, but sometimes it becomes part of a conversation. We'll have homeowners ask, how do I increase my energy yield, and so at that point it can become a conversation where we can look at deleting this tree or that tree from our modeling, and then understanding the net benefit if there is one.
And then I was just wondering too, I have a south-facing wall. It gets pretty good sun in that the siding is warped. The wood siding is warped, so the sun is very strong. But I'm wondering if you ever do wall mount.
We can with BIPV. Is that correct, Tim?
Yeah, we also have looked at wall mounts with standard solar. It similar to ground mounts, like it becomes a little bit more of an exercise in a sense from like a design and engineering standpoint. Because we're now, instead of being flush off of a roof plane, we're now taking a wall and probably making the panels sort of an awning off the wall. And so then you've got much more wind uplifts, and so it just has to be custom designed and engineered. So again, that might give us more gain in terms of production, something that could be worth exploring. But what does that and extra energy gain translate in terms of extra savings versus what would be the additional cost in doing so? But maybe it turns into a shaded area as well for hanging out. So yeah.
Solar canopies are a thing in parking lots everywhere. It's pretty cool. In France, any parking lots over 80 spaces has to, by law, have solar canopies now.
I think I've seen those photos. I'm realizing we only have 4 minutes left and Lee has his hand up. So let's get to your question, Lee.
What's the cost benefit of bifacial panels and a ground mount? Does the extra cost generate, does it pay off?
Yeah, bifacial panels are very similarly priced to monofacial. At least how we budget our projects. Other installers might treat them a little bit differently. They're a little bit heavier. Quite often they're double glass, so glass on the front and glass on the back. I would say it's absolutely worth it on a ground mount. It's something that's kind of hard to quantify, but just theoretically makes sense. The one thing to be aware of is that, depending on, you can get a bifacial panel, but if you get a ground mount that has rails, so if you're putting rails down and the solar panels are going down on top of these rails, so my hand is a solar panel again, you have a rail here and a rail here, that's now obstructing the bifacial gain as well. So generally, with bifacial panels, there are racking solutions that are, promoted to be enabling for bifacial technology as well. So that would be something to look for.
Thank you.
And Shal, I think this is our last question for today. So we're at 2:58. Please go ahead.
I'll make it quick. So our community center is actually the beginnings of a solar demonstration park. We have 4 different arrays. We have a roof mount and 3 ground mounts. We have 1 ground mount fix, 1 ground mount with a 1-ax tracker, and the last one has a 2-axis tracker. All 3 in the field on the ground use bifacial panels. I'm just going to talk about the roof mount and the ground mount fix with the bifacial panels. I think who was it earlier that mentioned that maybe the ground mount was like a third more expensive. Solar bifacial panels, so far we've only been online since January this year, but so far they're 17 to 20% more efficient, and what we installed the ground mount with that is like 2 times more expensive than the roof mount. So long story short, maximize your roof mount. That's where you get more bang for your dollar.
You're hired, Charles. Yeah, like Tim said, it's all about running the numbers, and that's what Shift does in our proposal. We lay all the numbers out for you, and we're obviously willing to go back and forth and look at things, and then it's a numbers game, and that's why, full circle moment. That's why a lot of people are looking at solar, because the numbers now make sense. So a lot of people are transitioning.
Great. So that is all the time that we had today. So I want to say a great big thank you to Chris and Tim. Merci for sharing today. The recording is going to be available on our YouTube channel later, and I'm sure from what I'm hearing, Chris and Tim, you're not opposed to people reaching out and asking further questions.
Yeah, for sure. I don't know if by all means reach out. Do you have our emails, or is there a way? Either way.
I mean, I have them, and if I have your permission, I can share them
Yeah.
with the follow-up to this, with the
Yeah.
recordings and everything. So once again, I want to say thank you to everyone for coming today and participating and asking all your questions. I hope this was helpful to you. Yeah, have a great day, everyone.
Thank you for having us.
Thank you.
Thanks, everyone. Bye.
Bye.
Good